section, which is a little bit more complex. So I'm not going to do all of these. I'm probably going to take just a couple and let you guys look at the rest. So again, this is an abstract concept, so we don't even have a function in this case. We're just told there is a function, f of x, so we don't know what f of x is at the moment. We know we have a function. And if I integrate this function between 0 and 2, then the integral is 4. Between 2 and 5, the integral is 12. And between 0 and 2, and actually in this case we've got two functions, haven't we? We've got g of x, so we've got two functions involved. So 0 to 2 for g is -3. Reminder, the fact that it is -3 means that area is under the curve, but the absolute value, the size of the area, is going to be 3. So let's just start by looking at the first one. So we're going to focus in on this function here. Bear with me. My Zoom is not working. Okay, we'll just do it up here. Okay, so I've been asked in the first section to find the integral of, well, between, first of all, 2 and 0 of 3 f of x subtract g of x dx. Okay, well, good news is we know what the integral between 0 and 2 for both the functions are. We know the integral for f of x between 0 and 2 is 4. We know the integral of g of x between 0 and 2 is -3. So all we need to do is to use those properties. But we know in this case we've got 3 lots of f of x. So this is going to be 3 lots of 4 subtract g of x, which is -3. So negative, just be careful with that. Okay, all we're doing very simply is using the values that we know because we have the same boundaries in this case. So I've got 12, add 3 is going to give me a value of 15. Okay, this time I'm going to look at, let's just carry on, I'll look at b. So we've now got the integral of the boundaries between 2 and 2 of g of x dx plus the integral between 5 and 2 of f of x. Okay, dx. Well, this is really just using two properties that you can write down as rules, but if you think about it, it makes sense. So we're being asked to integrate between 2 and 2. Well, if I've got any graph, whatever that shape may be, and if I'm being asked to, well, we've discussed the idea of definite integrals is looking at between two boundaries. So say we've got these two boundaries, one here and one here. Well, if we're just integrating between the same two boundary, then there is no area. So because we are integrating here between 2 and 2, the boundaries are the same. We're not actually well, the area is actually equal to 0. Okay, this case, there is a problem here. We're integrating between 5 and 2. We want to integrate from the highest value, well, the highest boundary should be at the top, the lowest boundary should be at the bottom. We're kind of backwards integrating here, which doesn't make much sense. But in addition, we are also told, so this is for f of x, that we know the boundary from 2 to 5 rather than 5 to 2. And we have this property here that we can just apply straight away. If we're actually, all we're doing is really reversing those two boundaries. Rather than going from A to B, we're going from B to A, we're flipping those over, and you'll find that that is the negative, because we're reversing what we're doing, the negative value there. So we've then got plus, okay, rather than integrating between 5 and 2, we know between 2 and 5 over here is equal to 12, but then we're also using this rule here, that gives me a negative value. So I've got plus negative 12, which gives me a solution of negative 12. Okay, let me do one more. I'm going to do C. Give myself a little bit more space. Oh, don't know what's going on there. Okay, let's see if I can just copy this over. No. All right, so we will write this out and then zoom out. We have, okay, we're integrating this time, so this is for c between 0 and 5 for f of x dx. Well, what do we know? We know the integral of f of x. We don't know what the shape is or anything about f of x, but let's just look at, for example, something like this. We do know, if I change these boundaries over here, for f of x, we know the values between 0 and 2. So we're saying between 0 and 2, so let's say this is 0, obviously it is, and 2 for f of x, if this is my function here, f of x, then this section here, oh, should have used a highlighter, missed opportunity, here we go. We know what that value is, it is 4. But we're also told that we know the area or the integral between 2 and 5 over here. And the integral between 2 and 5, let me just change this boundary slightly so it makes a little bit more sense. It's obviously going to be a little bit bigger. Let's say it's over here. So we're then going to, we also know the area between 2 and 5, and we're told that area is equal to 12. So, kind of intuitively, we can deduce that if we're finding the area between 0 and 5, we're just finding the sum of those two areas. So this is then equal to 4 plus 12, which is equal to 16. In each case, we don't really need to put the units. It's fine just to leave that as those values equals that. Thank you.